thought I would. I have this view set up here, so I thought I would show her. Oh, she's purring. If you're watching this video after the fact, make sure and check the comments for time codes. This is going to be like 2 hours long, so if you want to see individual bits of it, take a look in the description and click the time codes to warp to the part of it. Let me stop my... Oh, and she's gone. Don't tear that piece up. I have paper on the floor that she shouldn't tear up. What a naughty cat, huh? Okay, let me switch. Live on Twitch, thank you, Mr. Certainly. I haven't paused my videos. Pause that one. And this one. I have upped my volume. Muted though. I'm muted? You can't hear me? Audio is super low. Yes, it looks, I see it on my side. Let me see. Does it sound like it's not coming here? Desktop audio mic. I see what you're talking about. I can up my gain. Which one is it? This one. Hello, 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 hello. That's like all the way up. Sorry, Is that better? I don't know why it's so low. Maybe there's other audio settings. Yeti. Playback device. Mic. Hover cam. Louder. Much better. Okay, well, it's... I don't know why. I might have updated OBS, but that's very weird. It's like super live, but I don't know why it was so low. That's like I can see the slider and huh. I'm not sure why that's the case. But thank you for letting me know, and that is why we start early. DCD, is it better on Twitch now? It's like, it's very, like I cranked the gain on the back of the mic all the way up. I don't know why. I mean, maybe I should unplug it and replug it in. I don't know. It's working now. I don't want to mess it up. Mr. Certainly, were you able to turn it down now? Hi, Anthony. Hi, Johnny. Hi, Armando. Hi, Randy. Hi, Unexpected Maker. Hi, David. Hi, Gerson. Yeah, weird. I'm at 90% as well. I mean, on my OBS, it doesn't look... It still looks a little low, but... Still low. Let me unplug the mic and let's... I don't want to blast you. That's the problem. But this is really hot. I know that. Sorry for the... Okay, now you're hearing me somehow other than... that. Can you hear me now? It's still really quiet, huh? It's set to the right device. There is not a mic in my headset. That's a good idea. Yeah, now it's really low. What's the ALSA mixer way of doing this? Default source 43%. More. Okay, I see. Default source. Volume control. Capture devices. Speaker. Mic. What's this do? Oh, here we go. Capture devices. Test, 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 test. Is that better? Better, better? Better, better, better? I'm getting into the yellow now. Much, much better. I turned it all the way up. Anthony says too hot. That looks right on my end. I can crank it here just a smidge. Test, 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 test. Randall says a bit hot. It's flat topping. I don't see it here, but it might be. I can crank it down just a smidge here. No, not too hot. All right, let's go with that. It was definitely like on the input, it was a little low. I don't know. I don't know how it got changed. I did do. No, I haven't done anything. Hi, D. It's just fine. Thank you. Sounds normal now. 45 people turning up and down their volume. Yeah. Sorry about that, folks. Thank you for bearing with me. Lots of new folks. Let me say hi. David says it's minus 17 Fahrenheit with wind chill in Wisconsin. I remember visiting. My mom's from Wisconsin originally, and I definitely remember it being pretty chilly there. One like Christmas that we went, it was like minus 30. It was cold. Hi Bruce. Hi Mark. Hi David. Hi Keith. EE. I sound normal now. Hey Jay for seeing. Hi Alvaro. Phil Moyer's in the chat, I think, and I just wanted to say I remember when we were looking back at CircuitPython 2020s or even 2019s, like Phil was like, Scott should do a deep dive and answer questions. Well, I think it's funny that we have that now. Greetings from Mars. Hi Brandon. Hey Steve. Hi David Buchanan. Hi Randall. Hi Rodrigo. Anthony. Johnny. Jason. D. Lots of folks. Thank you all for joining me. Sorry for the audio problems. I'm glad we got it sorted. So let's do housekeeping. Mr. Certainly says, aside from audio troubles, how are you doing, Tanu? How's your Friday been? Good. I'm like so close to getting I2S audio working, so I think that's something we'll do today. Thank you, David, and thank you, Daniel. Now is one of the rare times we do actually have a little snow on the ground here in Seattle. Good morning, Mike, which is kind of exciting. We're supposed to get a bunch more tonight, so we'll see how that goes. But we don't have any plans. My audio, the video looks okay from here. Would just be my luck. Good. Okay, cool. All right, let's do housekeeping so we can get the show on the road. Daniel says audio and video is okay. Thank you. All right. And look, Vin, this is the other cat. She's actually in the cat cam right now. That's Vin. She usually is the one that gets up and like leaves because she doesn't like when I talk. But she's choosing to be in here with me when I'm talking because there's cleaners outside the door. And they're scared of vacuums. So this is her choice today. Okay. 10 minutes in, we'll do housekeeping, which is kind of standard for us. So I'll take a time code. Hello, everybody. My name is Scott, and I work for Adafruit on CircuitPython. If you don't know what those are, Adafruit is an open source software and hardware company based out of New York City. I work remotely for them, so I'm actually in Seattle. But they do lots and lots of cool open source stuff. The focus of the company is enabling folks to use electronics to do the projects that they like. And we create learn guides to teach people how to do different things with electronics. So check out learn.adafruit.com for those. If you want to support me and support Adafruit, go to adafruit.com and buy some cool stuff there. We'll talk about some of the stuff you can get from Adafruit later. CircuitPython is a beginner-friendly version of Python designed for microcontrollers, which are these little tiny computers, and I'll show this again. Let's go into Product Showcase. Oh, I was in Product Showcase. This is an example of a microcontroller, this chip in the middle here. It's a 125 megahertz processor with 264 kilobytes of RAM. And these boards they go for, it's upside down. They go for $4 a piece, which is really cool. So it's a great way to get started with programming, and CircuitPython is our platform to make it as easy as possible. So if you haven't checked out CircuitPython, I highly recommend it. And yeah, I love this camera. I was just, Sean Hemel was wanting to replace a webcam, and I was like, dude, I love this camera. So I just clicked a button. Now it's like an eye tracking mode. Also, is that a lawyer? She's not a lawyer. She's just a regular cat. There's a bug on my cat's head. That's her coloring. She's got that little splotch. And then her brother has like a bigger splotch as well. Speaking of cats, let's go out of order. The other cat, Spook, is down here in his crate. Again, hiding from the cleaners. He is epileptic, so he does have seizures from time to time. He's been doing really good, though, so I don't expect it to happen. So just if I'm on screen but not communicating, that's what's happening. I'm just watching him with that. Oh, two great questions. Hold your questions. Let me finish housekeeping. We'll get to questions after that. So let me finish up. If you want to chat with me and a lot of others throughout the week, please join the Adafruit Discord server by going to adafru.it/discord. 2 cats for the count. And they're both in here. Last up, this is a deep dive. It happens every week on Fridays, normally at 2 p.m. Pacific, because I'm in Seattle. It's occasionally shifted to Thursdays at 2 p.m. if I want to have Friday to myself. And typically it goes for 2 hours or more. So we've got a couple of questions already, which is great. And we'll cover questions until we want. Next week is on Friday. And then also, there's a chance Ladyada will stop by later too. She did last week, and she was asking like, hey, can I stop by this week as well? And I was like, of course. So we'll probably do that in an hour or so. Okay, so there's a couple questions. Let's start with those. I do have some projects I want to show, but let's do questions first. So the first question is, is the cat a lawyer? If you don't get the reference, there's this awesome meme of a cat with a lawyer with a cat filter in a Zoom call. So it's quite hilarious. But no, Vin is not a lawyer. She is named after a main character in a book, though. So that's one question. David says, Go Seattle, was born there and lived there until 9 years old in the 50s. Fond memories. Awesome. My dad is around that age, too. Okay, so Gerson, I hope I'm saying that right, says, does the Pico have Wi-Fi? Let me switch to the desktop. The answer is no. But if you've used Adafruit stuff before, let me get the window the right size here. I have a bit of a different keyboard and mouse setup that I will show in a bit. But if you just look for AirLift here, so AirLift uses an external processor here, and this setup it should work with the Pico. So if you get one of these boards, you connect the SPI, And there's, I think, is it under assembly? So here's how to solder it down. And then if you want Wi-Fi and CircuitPython, here's how you hook it up. You'll, of course, have to change this pin mapping, but the library itself should work the same. The Pico itself does not have Wi-Fi, but you can use an AirLift board from Adafruit as a coprocessor to provide Wi-Fi to a Pico. And I'm a little bit behind, so D, I see your question, but we'll do Randy's first. And let's make sure that we're... thank you, David. David is awesome in doing notes, so thank you to David for that. The next question is, when is CircuitPy and the Feather 2040 going to be released? The question, it's a matter of when Adafruit gets chips. Officially, they've said Q2, but you never know when you're going to get them in the mail. So they will be released as soon as we can make them. I am one of the lucky folks. I have a prototype Feather 2040 here, and it's actually very, very useful. So it's going to be cool. And I suspect that ladyada is actually, she wanted to drop by to show the CircuitPy as well. So we can ask again later about that too. Okay, Brandon says, did I miss anything in the Discord chat? I don't think so. Oh, Bruce says, oh yes, I saw something about moving to 4.3 for the IDF. Is that an actual thing or a hope? If somebody does it, then we could do it. I'm not gonna take it on right now. So Brandon says, what's the advantage/disadvantage of using a Pico over an Arduino? And this is where a distinction is really important, is that if you're talking about the hardware itself, right? So take like this, for example. So here's the Pico, and I'll do product showcase again because I like it. So here's the Pico, and then it's not an Arduino, but it is an Arduino Uno shaped Metro. Metro is the Adafruit brand name for something that's Arduino shaped. I don't think this board has a lot of advantages. I mean, it's very inexpensive, so it's $4. So if cost matters to you, that's a great place to start. And if you have a choice between this and like an Arduino Uno, the Arduino Unos are 8-bit microcontrollers, which means that they don't run as much software. So they won't run MicroPython or CircuitPython. So you want to make sure and if you're looking at a particular Arduino board, you want to go for something that has a 32-bit microcontroller like the Arduino Zero does. Yeah, so you have to make sure and get a 32-bit one. The nice thing about a Pico as well, and the RP2040, which is the chip, is that it's got 256K RAM or so. So if you do use it for Python, there's a lot of RAM that you can use for it. So Brandon, if you have more specific questions, let me know. Gareth also says Pico versus the ESP32 is more interesting battle. Yeah, I was thinking about this. I think, we support the ESP32S2, which I have somewhere here. I mean, it's just another board, right? The ESP32S2 is interesting because it has native USB compared to previous ESPs. And it has native Wi-Fi. So if you want to do something that's connected native and has native Wi-Fi, the ESP32S2 is the way to go. But it's more expensive than the Pico, and the Pico is going to be more real time. So if what you want to do is shuffle around bits and bytes and stuff, like the Pico is actually really, really good at that. It's only where you start doing like floating point, like decimal math, that it gets a little bit like out of its element. So I hope I answered that. Over the ESP32 line. Well, so the other thing to consider about, especially if you're a newbie to microcontrollers, is the documentation that comes with something. So the ESP32 datasheet is getting better and better, but I felt like when I got the first draft of the RP2040 datasheet, it was better than the ESP. So I think, and there's a lot of tutorials and stuff already written for the Pico. So if you're getting started, the RP2040 has a ton of documentation, and that can't be beat. And that can't be, like, a lot of people say like, oh, ESP32s are as inexpensive as a Pico, but they're usually purchased from a supplier that doesn't support them and doesn't provide documentation about how to use them. So you have to think about that as well. Okay, let's see. Next up, question from Johnny says, have you seen the little VGL graphics library? They have MicroPython support. I have seen it. I'm open to doing bindings to it, but the way that they did the MicroPython bindings, I don't like, because they basically just expose the C binding, the C functions directly, and they didn't do any work to like Pythonify it. Like using objects and things like that. So I'm not a huge fan of their MicroPython support. I think it's done in a fork as well. I don't think it's in upstream MicroPython. But they are doing some cool stuff. And there's also really cool some work that folks in our CircuitPython community are doing to do more widget-like stuff. So KMatch98, Foamy Guy, and I feel like there's like 3 folks that are doing it, but there's some really cool graphics work already happening in CircuitPython as well. So yeah, little VGL is really cool, but it's a lot of work to create a good API on the Python side, and then all the tutorials and stuff to go along with it. Davey says, is it fair to say that unlike Raspberry Pi, you always have a graceful shutdown with unexpected power loss in CircuitPython? I don't think that's fair to say, no. I think, CircuitPython does reads and writes to the file system, and if you get interrupted, that could still be a problem. I think maybe it's less likely because the core code itself is not writing to it. But no, I don't think it's quite that clear cut. From Discord, Neradoc asks, do we need chip documentation when we have CircuitPython? Well, you're not going to get a good CircuitPython implementation without good chip documentation, let me tell you that. But yeah, like if we've done the work to make things, unexpected maker, I haven't seen the editor, so link me and I'll pull it up and take a look. Oh yeah, TG Techie, thank you, J for Zian. Has also been doing a lot of graphic stuff for a while now. Toddbot points out that Arduino is also coming out with an RP2040 based board soon. So RP2040 is the chip on the board, and then the board itself is called the Pico. Slinky Tangle says, can I implement a high-speed counter in PIO? Cycle accurate at 50 megahertz would be fantastic and could replace hardware or FPGA currently required in our lab. If you're just counting pulses, I think so. I was actually just thinking about this because I want to do some run length encoding stuff. You certainly can run, like you'd probably need 2 instructions, right? Like wait for an edge and then increment. So if we just look at, this is the data sheet here that I've got. I think like it's counting is a little weird. Like you certainly, like it depends on how, I don't know exactly what you're counting. Like you can sample at 50 megahertz for sure. But if you're getting 1 pulse every 50 megahertz, it might be a bit more of a trick. Yeah, Mark says, I think the pulse at 50 megahertz is possible, but it's not an exact divisor of 125, so there will be some jitter. The divisor is fractional, though. So I think you could actually maybe do it. It's certainly worth a look. But yeah, you can only count down. You can't... I don't think you can count up. Right, there's not really a lot of math in it. But the other thing to think about is that you could, there's two Cortex M0 cores. So you can always just use a Cortex M0 doing just what you need. And it has single cycle access to the I/O. Okay. Wintermute says, "You're brilliant. I love your work." Thank you. A lot of this is just not my work. Okay, let's look at this link. And remember, I'm a little backlogged on... Whoa. I haven't seen this video. Is the audio worth it? I know you can't hear the audio. I think some folks were thinking about doing this as well. It's a matter of like what widgets you have and all that. Yeah, LVGL is doing some really cool stuff. There's just music playing, so there's no audio or anything. Yeah, that looks neat. Like, I don't know. I think, to some degree, it's like we can only do so much. My personal interest changes from different things anyway, so that's a bit more of a trick. But yeah, like, I would love to see all of this stuff done. Like, I wish I could snap my fingers and just have everything done. Yeah, I'm not against it. I just play it at 1.5. Is it worth a while? What is it? Oh, for like... I don't know how to change the settings. Huh. Yeah, it reminds me of the cute stuff as well. Sorry, I'm jamming out and you can't hear. Ah, Garrett says, 1 minute summary of what little VGL is, please. It's a C library for microcontrollers that does embedded UIs. Yep. Yeah, sorry. Thank you. I should have started with that. Okay, I'm behind. Hello, person whose name is in Arabic. Sorry, I can't read your name. That's my failure, not yours. David asked, what will be the audio frequency, resolution, and accuracy, for example, generate a 167.9 hertz tone in Pico? So, I haven't run the numbers. So you're doing 125 megahertz base clock. And then depending on if you're doing PWM or I2S, you have like a divisor that gets you down to your sample rate. And that'll dictate what your sample rate is. And then you can overlay, whatever sine wave on top of that sample rate. I know with I2S, I think with PWM, I was able to do 10-bit 44.1 kilohertz stuff. The tone is more achievable than 50 megahertz. Yeah, we're going to do audio stuff later. And I do have a demo, although I've changed it. I had a demo of the PWM audio stuff playing. Let's keep doing questions, and then we'll do some stuff, and then ladyada might drop in. Randy asks, where does thorny store libs in MicroPython? So thorny is an IDE that the Raspberry Pi Foundation is having everybody use with MicroPython. When you copy file libs over, they get stored to the internal file system in MicroPython. And they're using little fs. So just like CircuitPython, where we show up as a drive because we have a file system, they have a file system as well. They just don't show you, like they don't make it accessible over USB. So it's stored on the flash. David says, I talked to a guy who was buying a Pico in line at the microcenter. He mentioned he was making a 3D printed robot called pypot or Poppy. Anybody heard of that? I have not, but we have a wide audience here, so hopefully somebody has. I saw Chris on, what is that? Twitter ask keyboard for the blind. Blind keyboard. Oh yeah, so segue. I have this set up, and thank you David for taking notes. I wanted to show this setup that I've got. So I made my overhead. My overhead's pointing to my hands, and so what I have actually is I've got I did this yesterday or the day before, is that I have it so that if I have my hand on my trackball, the lighting of the keyboard changes and the right hand becomes mouse clicks. So now if I do like that, that's a right click. I know you can't see the desktop, but if I do this, I guess, so you can't see me move, but I can drag, maybe? Yeah, it's kind of hard to see. But so all the mouse buttons are now on the right hand side, and I have mouse wheel scroll up and down as well. And so the way that I'm doing it is, the problem I had was I got a new trackball, and its buttons are like way on the side, and I was using my pinky finger to press the button, and my hand just from one day was starting to get sore from doing that. So I had this idea a long time, but it was kind of urgent, so I finally did it. So what we have here is, this is an Adafruit board, the VCNL 4040, which is a proximity sensor. So it's being read just by, so I have it running here, which is this is a SparkFun quick feather board, and then there's a Feather M0 Express underneath. So it's just like 20 lines of CircuitPython that's reading the proximity and sending a signal out. So the signal goes out off screen, comes back. What this is this is an audio or an analog mux. So it's basically like pretending to close the contacts on a switch. And then these two wires here, I don't know how, well, wait, let me start over. Well, not start over. Okay. So feather, stemma, this is it's converting like a proximity value to a signal. The signal runs out and around, and here, this is the analog mux. And then the analog mux connects these two wires. They go into the keyboard here through some screw holes that I took the screws out of. And they essentially press this key here, which is, this is a keyboardio, and it has an LED key. So I'm pretending to press the LED key, and I've configured it to be in a mouse mode when that happens. So I turned off all the LEDs on the left-hand side, because like, I shouldn't be able to press it because my hand should be over here. So it doesn't do any, well, it will do something, but I don't use it. And then on my right-hand side, I can do like left click, middle click, right click, up, scroll up, down, browser, back, forwards, that sort of stuff. So I've just switched to that, and you can see my threshold's just a smidge off. Like, if my hand's too curved, it doesn't detect it, but if I go down, then it does. So I think like there's a number that I have to just tune just a little bit. But the nice thing is that because it shows via the LEDs, I can tell whether it's paying attention to me or not. So yeah, I'm pretty happy with it. It means my right hand actually stays here a lot more, which is a good thing, I think. So that's keyboard stuff. Otherwise, I think we're caught up on questions. If anybody has any other questions, we've got about 30 minutes until I think Ladyada will duck in. What else was I thinking? So audio, we could talk audio. Oh, I do have something to show. Do you need audio feedback on proximity? I usually, yeah, thank you, Alvaro. That's exactly what I was thinking. No, I can usually catch the LEDs out of the corner of my eye. Oh, David Glad asks, what is this clue doing here? Well, this clue is the clue running David's code to do timestamps that I've been really bad about. But I do have that there in case I'm doing timestamps. So thank you, David, as well. Okay, let me switch to the camera again, and then I got a request because somebody knew that I got this. So when Espressif announced that the ESP32C3 was going to be available early to some folks, I emailed them and got on their list. Yeah, another David's doing the timestamps. Yep. Your timestamps are 5 minutes off? Oh, so let me look. I'm at 35:51. This timer is maybe a second ahead of me. Yeah, Gareth says, is this the RISC-V one? It is the RISC-V one. Yep. So this is, I think they're gearing this to be an ESP 8266 replacement. So I'll open it up. So it slid out and it came like that. And then you pull the tab to take it out. And I will just show this. It looks like all ESP ports, really. It doesn't have native USB, so I believe this board actually has a USB to serial connection. And then you can see that there's a module there. So that's just the dev board they sent. I just got this one. It is really neat to see CircuitPython, RISC-V as a core. I have not played around with this at all myself, and in fact, I probably won't anytime soon. How does it hold on a breadboard? I have a breadboard. Yeah, it leaves one row on each side, I think. Yeah. And where do they have a solid here? Yeah, it looks like it's one row. It's one row less wide than a Sala, so that does mean that you get one row on each side, which is nice. Gareth says, "What about the CircuitPython potential?" It's a long-term thing. It's not going to be done in the short term. The thing is it doesn't have native USB, so it wouldn't be able to. Well, this one's a weird one. It doesn't have full native USB. What it has is the production version will have a built-in USB to JTAG and serial converter. It will not have a generic USB peripheral. And so that means that we wouldn't be able to do the CircuitPy drive on it, which is why it's not high on my list. In the longer term, I've talked about this before. I really want to do BLE file sharing, like saving and loading files over BLE, and also the serial output over BLE. So that is higher on my list. And then once we have that, we'd be able to support boards that don't have native USB if they have Bluetooth. And this, not just Bluetooth, but BLE, and this has BLE. So long term, yes, we could potentially get this. We could also get the older ESP32, which I think a lot of people would be excited about. We could get the microbit V2, which I still have on my desk here. It would be cool because since I'm in product mode still, the chip on here has native USB, but they didn't connect it up, which is a weird decision in my book. But it would be nice to use. David G says, if we get BLE workflow, then would the old ESP32 be interesting for CircuitPython again? Yes, I think so. Yeah, I mean, there's so many of those ESP32s. The question really is whether I lost my train of thought because I was thinking about RISC-V. With ESP32, whether the ESP32 regular is actually going to be as popular as it is now by the time that we get to it, right? Because there are these other chips coming out that are more interesting. Phil Moyer asks, would it be easier to use a different RISC-V dev board for porting CircuitPython? And Alvaro points out that there are now 32-bit RISC-V chips with native USB. So the thing is that RISC-V itself, from a CircuitPython standpoint, is not very interesting. And the reason that it's not very interesting is because RISC-V is very, very cool overall, because it's a standard API for a CPU. And that means that all of the software tooling on top of that can be the same. But when we do ports for CircuitPython, we always already have like the compiler tool chain and all of that stuff. So RISC-V in of itself is not that interesting to us, because the effort we put into porting is not due to the CPU. It's due to all of the peripherals around the CPU. And so like the C3 is probably not that bad of a port because they have the ESP IDF and we just use that. And we've kind of ported to the IDF already. But for these other RISC-V chips that folks are talking about, like, it's the peripherals that are the hard part. It's not the CPU. Almost always, it's not the CPU. Like same with the Pico, right? Is like all the effort's been in like, okay, given these peripherals, how do I implement PWM-IO? How do I implement Pulse IO? How do I do rotary IO? How do I do audio? Like that has nothing to do, like we already have a Cortex M0 in the SAMD21, like we had that ages ago. So yeah, RISC-V itself is very, very cool. But you also have to think about that, like RISC-V is just the API. So not only does it matter what the API is, but you could also think about the actual implementation of that API as well. Could be interesting in the long run. And the API like has different modules that it can have, just like kind of CircuitPython does. Yeah, so it's cool. It's just early days. But like, I'm not like, oh, I got to use this C3 because it's got RISC-V on it. Like, if I cared, like the ESP32S2 actually has a RISC-V core in it. It's just the like ultra low power one that runs at 8 megahertz, like, which I think is going to be, yeah, we talked about this before. It could be cool to do like assembly level stuff, just like the second M0 core. Yeah, Gareth says, okay, great. Yeah, BLE would open so many doors, accessibility to folks with just a phone, etc. Exactly. And that's why I have to be like, look, I need, like, I've wanted to do this for years, the BLE workflow stuff for years, and I got to do it, and I can't let myself get sucked into C3 and soon to the S3, both of which would benefit from having a standard BLE workflow in CircuitPython. So kind of my plan is like, for my personal work is like, we got to get through this RP2040 bubble. We've got a lot of people asking for UART still. We've got a lot of people asking for infrared. Like, we got to basically do all of the modules in RP2040. And then once we do that, BLE workflow is my plan. Like, I got to go heads down before I get sucked into these new ESP chips or other chips that come out. So yeah, that's my outlook on my work for probably the next 6 months. Unexpected Maker says, once the S3 is out, no point in trying to support the previous versions. If it's low, like if we add Wi-Fi and Bluetooth support for the S3, and that just automatically means it works for the ESP32 as well, like we could do it. Like if the cost of doing the older chip is low, we might as well. We might as well, because there's so many people that have it already. And we, Adafruit, have products that use it as well. Okay, so let's... did you all see my audio example with PWM audio? I'm not sure. I think I covered everything I wanted to talk about otherwise. Yeah, so we can do that. I mean, the more boards, the better. Yeah, David G says, could the AirLift coprocessor become the main processor? Yeah, totally. Complete with bugs. You know that's all I do. I don't squash all the bugs. Okay, let's do some audio stuff. So let me take the cam and arrange it. I'll show you what I'm doing here. Okay, so there's my desktop. Oh, and I got this like nice cushy thing for my wrist as well. I don't know if you noticed that. So what I've got going here right now is this is the RP2040 Feather, and I'm working on I2S, but I don't think I've shown the audio demo yet. So I'm actually I'll just switch this briefly, and we'll do the. Yeah, I think the PWM thing should work. So. Or maybe I'll just show, let me show you what it's doing right now before I change it. What I was doing last. So as you can see that I've got 4 wires going from the Feather. I've got a yellow one that I'm using for the like capture trigger. So that's not actually doing the protocol. And then I've got 3 wires here where I'm doing I2S. So what I'm doing is in my code.py, basically I'm prototyping the PIO assembly. Oh, sorry. Oh no, see, this is what happens when my hand's not low enough as I type ends. I was noticing like in some of my stuff, I'm like ending comments in ends. Oh, you can't see my screen. So let me show this and maybe I'll make it. I can make it a little bit bigger. Okay, so this is my prototyping. So what I'm doing is I'm prototyping the PIO assembly that I'm going to bake in the CircuitPython for I2S. Hello, Hugo. Phil Moyer says, I'm really looking forward to the 2040 Feather, mostly so I don't have to bodge LiPo with power boost. Okay, so what do we have here? We have imports, we have audio core, audio PWM IO, which I don't actually need. I'm not using that. Board, digital IO, array, time, math, RP2 PIO, and Adafruit PIO ASM. So this is a Python library that converts this big long string to the bytes of the instructions that actually get saved to the state machine. So if you're watching the stream for the start, the PIO is a peripheral on the chip that basically has 4 cores. So each PIO, there are 2, has 4 state machines, and the state machines are very simple logic, not kind of Turing complete, meaning like a CPU is Turing complete. But it's a state machine that allows you to do very fast inputs and outputs for different types of protocols. So what I'm doing here is I'm working on using that for I2S. And so let me just go over here. So trigger, and I have a good data sheet that I'll show it as well. Actually, maybe let me show the data sheet first. So if you don't know what I2S is, oh, and I'm typing ends again. Here's a good example. So I2S is a digital audio format that's really common. It's not I2C. I need to get Twitch credentials. I think the people I blocked just go and restream. So I2S is a digital protocol where, if I can make it as big as possible. Oh. There we go. So this is the data sheet for the UDA 1334, which we don't actually sell anymore, but I happen to have somewhere. And what it does is I2S is a way to send the digital values for this audio sample. So audio is you take voltage over time and it changes the position of your speaker, causing sound waves to happen that you can hear. So audio is all about shuffling numbers at a particular frequency to change where a speaker is. So what I2S does is it has WS, which is known as word select. And so it's for stereo audio, which means you actually have just two, like in my headphones, right? There's like speakers that are moving and they're moving at a certain, like they get a new value every so often. Like CD audio is 44.1 kilohertz, meaning you get 44,000 samples per second. So what's happening 44,000 times is you get this pair of values. So the way that works is you have a word select line, which is like your slowest clock, and that defines the boundaries of each sample. So if it's low, it's on the left side. If it's high, it's on the right-hand side. And then you have something that looks an awful lot like just like a SPI protocol, where you have a clock. B clock means bit clock. Word select can also be known as frame or left-right clock. So bit clock is what clocks each individual bit. And it's showing you here that like it starts with the most significant bit and goes down. Now I2S is a bit weird. It's a bit weird because the least significant bit actually occurs after the word clock has changed, which is very strange. But it means you have to delay one. So that's classic I2S. But then there's also, if we look down here, there's least significant bit justified format, 16, 20, and 24 bits. And so this is nearly the same, except the last least significant bit occurs prior to the change in the word select line. I still need to figure out what those people are doing over I2S, matrix stuff over I2S are doing and why it makes sense to them. Do they make a sound picture and run it in a loop? Well, right, like, I don't know the Hub 75 protocol, but this is like, at least on the ESP32S2, I think they actually had the ability of like having more than one data line at the same time. And then the clock managed for you. So I think that's why they can use the I2S peripheral for it. Okay, so this is the output format we're trying to create. I should say I started with the example from the Raspberry Pi folks for this, so I'm building on what they're going to do. But one thing I had to do is in CircuitPython, when we're playing audio, we allow you to pause and resume it. And when you pause audio, basically what you want to do is you want to keep the same value, because that means that you're not moving the speaker at all, right? And if you're not moving the speaker at all, you're not going to create any sound. So what I had to do is take their example, modify it so that we could hold on to the previous value if no more values are present. So let's see how we do that. So what we have here is the trigger switch, which is just for the capture. This is the length, and then we do some math to produce a signed 16-bit array of just one sine wave. And it signs all values in I2S are signed. So that's good to know too. So here, let's look at this PIO program. Now this is the left justified version. This is not the old I2S version, because that's what I was just adding is the left justified version. So here's what happens. The first instruction we do, so in PIO, anything that starts with a dot like this is called a directive. And so that's not an instruction. It's just something that states about it. Gareth says, but maybe you don't want to hold the speaker in a single position for a long time. Yes, if that takes power, probably. So what if you need to like turn it off for a while, what you can do is you can like take the value that it's at and then move slowly to 0, which is usually the neutral position. And so what you have to do is you actually have to like slowly ramp the value to the quiescent value. Which we don't do. We do in some ports, but not others. And this is what causes you to hear pops. Like if you ever hear pops of things, it's because like we played the last value and now we're going back to 0 all in one go. That will cause a pop. So yeah, if you want to help make our code better, that would be great. Okay, so dots are directives. Anything after a semicolon is a comment. I think // works too, but semicolon seems to be the way that they do it in their examples. So these are all comments. If the line is like not indented and it just has a name and then a colon, that is what's known as a label. It is not an instruction, but basically it's a name of the next instruction. So if you see here, it's like jump to bit loop 1, that bit loop 1 gets replaced with the index or address of the label of the instruction the label points to. Okay, so what instructions do we have here? So we have pull, no block. So pull is a way to, there's two FIFOs, so they're queues, right? Luke says, you will get a slight pop if you suddenly go to repeating values, but it's nowhere near as bad as stopping the bit clock. Ah, interesting. Yeah, that makes sense, right? Because like you're still changing the information that you're doing. Thank you, Luke. Okay, so what instructions do we have here? So this left right clock and this bit clock are straight out of the example from the Raspberry Pi folks. So pull, no block. So pull is, I have a TX FIFO. So a FIFO you can think of as like a number of values that you've queued up to output, but you're not ready to output yet. And a FIFO is great because it can store those for you until you need them. If you didn't have that, you would have to make sure that the thing that was giving you the numbers was really exact and when it gave them to you. So a buffer, a FIFO, is really nice because it gives you flexibility on how you get the numbers to the state machine in this case. So pull no block says pull a 32-bit number from the FIFO if that is there. The no block says if there isn't any buffered up, instead what it does, and I didn't realize this to start with, but it's in the docs, is that it will copy the value from X. So it says here, a non-blocking pull on an empty FIFO has the same effect as move to the output shift register X. The program can either preload the scratch register X with a suitable value or execute a move to X from OSR after each non-blocking pull to keep the last value. So that's what we're doing here. Is that we do a pull, no block. So if there's something in the FIFO, it gets moved into the OSR. If there's not, we move X into the OSR. And we do a side set with the left right clock and the bit clock high. So we're doing something, we're not changing the output, but we are side setting. And then we do this move. So this is moving the OSR register back into X. So this is if we got something from the FIFO or not, copying it back into X. So whatever we're about to output, we're going to copy it back into X so that we can repeat it next time. The side set's the same. So like if we're looking, so side set 1-1. So if we look at the data sheet, so where are we here? So So we are in word select high and bit clock high. So we're right here. And we're going to take 3 cycles, 1, 2, 3, for this particular like high edge. So that's important. We'll get there. So we have 3 instructions here, all in state kind of 1, 1. So we pulled, we stored, and now what we're doing is we're doing a set y14. So this is the number of bits minus 1 that we want to output. And why is that? And see, we're still here. So now after we set y to 14, we output pins 1. So this is shifting, this is setting the out pin. We only have 1 to the value of the highest bit. So we're shifting left, and that's further down. So this is the most significant bit. We're side setting, so we're going to 0, 0. Oh yeah, we're not. It's possible this code is wrong too. So we're actually here. Like we're transitioning, we're getting the next high bit. So we were high, high, and now we're going to 0, 0, and we're outputting the first bit. Okay. Postmates. Sorry, I'm lost. Yeah, you jumped in the middle. We're doing assembly for the programmable I/O on the RP2040. Okay, so after we output the highest bit, it's shifted, right? And then we say, okay, if if y is not 0, then we do a jump. And that goes back to shifting another bit. It goes back up. But at the same time, if it's not 0, we subtract as well. So that's why you can think of it being inclusive. Like 0 to 14, that's going to happen 15 times. So that loops over all of the bits, and that's all of the bits with the left-right clock 0. And then the reason that we have this, so this is delay. So this is causing an instruction to take more than 1 cycle. So every instruction here, jump, out, set, pull, move, they all take 1 cycle by default, but you can slow them down. And that's what this is doing. So the reason that there's all these 2s here is that it's making each of these steps take 3 clock cycles rather than the 1 they would take otherwise. Remember, it's 1 for the instruction and then an additional 2 delay for a total of 3 cycles per line. And the reason it's 3 is because we have this thing up here, which is actually 3 instructions that each take 1 time. So in this 1, 1 state, we still want to spend 3 cycles. So like if we can optimize this further, we would be able to reduce the number of delays on the rest of the instructions. Okay, so that's delay. So bit loop 1 is really poorly named because I changed it. I think it was originally bit loop 1 because the left right clock was high, but I changed it because when I was looking at this, oh, it changes. I was looking at this classic I2S where left is first, but then on left justified it looks like left is high. So I could flip it. That's not too bad. And in fact, let me just do that. So we're just going to invert this. Oop. And this is the left justified version. Oop. Change my. All right, so now I've switched it, and you can see that the bit loop 1, bit loop 0 match up now. But the names are just names, so it doesn't change the way it works. It just makes it a little bit more readable. Okay. So this these 3 instructions run for a total of 16 bits because you get 15 with the jump, and then the last one is the 16th bit. And the reason that you need the 16th bit is because you want to do something different, not the jump, after it. And so you maybe I should, I don't know how I like indented or like had extra lines to like segment them together. But like these 2 lines will do 15 bits. These 2 lines will do a single bit. You can see that they both have the 1 0 and then the 1 1. And so the second time we're setting Y again because we're gonna count the next number of bits. And it's the same thing except the side is now 0, not 1. And then we loop around, and here you can you can see at the end here we don't have that second set. Instead, what we have is we have to pull and then the set on its own. Okay, let's keep going. I will actually run this, and then we'll see if we hear from ladyada. Okay, so right now I'm using init to send pin direction. I'm not liking this way of initializing the pins the way you expect, so expect to see some API changes with this. We'll probably leave init because it could be handy. It's a nice escape hatch, but we need to have better defaults for what the pins do by default. So frequency is how far I'm running it. This has nothing to do with audio. This is just for my testing and capture. First output pin is D12, so that's where the data is going to go. I have set pins, and I have 3 of them for the 3 that I have in a row, and that's just to turn them on for output. Once we have good defaults for stuff, we won't do this. And then for side set, we start at D10, and we go 2, so that's for the bit clock and the left-right clock. And then auto pull, we have false, because we don't want any of these out instructions to inadvertently pull anything. We want to do the pull ourselves. So turn that off. Out shift right is false because we want to shift to the left to get the most significant bit first. Pull threshold 32, which is actually the default, but it's still nice. I'm just standardizing on doing 16-bit samples. So every time we get something from the FIFO, we're going to end up getting 32 total bits. We'll get 16 bits for each left and right. There's a cool thing, and Luke, I don't know if this was your idea, but I talked, I think last week, about how the mirroring of the DMA works, where if you do like a 16-bit DMA, the other 16 bits and the 32 bits total will be the same value, but in a different spot. Like the DMA always does 32 bits always to a peripheral, and the width only dictates like, it only dictates like the source width, and then the remainder gets filled out with copies of that source. And so this is neat because if you have a mono 16-bit sample, where it's just 16 bits of every sample right next to each other, is you can DMA 16-bit, 16-bit, and then the striping or whatever it's called, where the DMA has the other 16 bits be identical, means that like we get for free mono to stereo conversion where both stereo channels are the same. Yeah, Luke says, yes, I think Graham used this trick for I2S mono as well. Yeah, super cool. The Code Gamers asks, what IDE is this? This is Sublime Text that I'm... Byte lane replication. Adafruit is so confusing, lol. I'm happy to answer questions if you have questions in the Twitch chat. But it is a deep dive. This is what people come for, is the details. But I can totally ask questions. Oh, I missed it. Gareth says maybe bitloop left is a better label. Yeah. And it could be used for triggers like wait until X pin is low or high. David G asked, what is the initial value of X? So I think it gets reset. So their state machines have the ability to be reset. And I think that the scratch registers get reset to 0 at that point. And so I assume it's 0 to start. And then as we load stuff in the FIFO, it will be 0. And then we'll hold on to the last value. And this is why signed is really nice, because in signed audio land, 0 is kind of like your middle, right? And that's usually what you want to start and stop with. So it's nice. If it's unsigned, then it's like half the range, which is weird. So yeah, I think the initial value of x is 0. And in fact, we can look. So let's see, did I go over all this? I did pull threshold. So wait for tx stall is something I added. When I did writes for neopixel, I made sure that all of the bits have been transmitted. But because we have this like default value, we never stall, means that Luke corrects me. So for those of you who don't know, in the Twitch chat, Luke Wren is watching, and they work for Raspberry Pi and worked on the chip. So yeah, that's one thing for us to do. State machine restart does not clear the scratch registers or the output shift register, so you need to initialize it. Yeah, and this is great. Like, this is something I've been thinking a lot about in terms of like initializing pin directions and all of that. So we'll have to do that as well. Like, we could clear it on our own. I like in CircuitPython to make sure that things are starting from a known state. So, you know, maybe we added yet another keyword arg that's like initial scratch x value or something. How to make a painter with Arduino LCD touchscreen. I think I know what you're talking about. If you go to learn.adafruit.com, learn.adafruit.com, paint. Let's see here. There's lots of light painters. Let's see what touch is. So go to learn.adafruit.com. I know I've seen. Here you go. This is what you're talking about. Where you can use your finger to. Here you go. Go there, follow the instructions. If you have problems, go on the forums. Phil Moyer says, but it's so exciting to start from random states. This is why people ask, like, oh, why can't I just read all of the state from my code.py in... I'm not going to... I don't have time to teach you right now. You can join the Discord as well. People can help you there if you have questions. But you have to try it first. You can't just ask for... You gotta have a more specific problem. And no, you can ask other folks there that they can help too. I don't do Arduino. Okay, so that got clarified. We should figure out how to get default state. That's a great question. So what can we do? What works at this point? So tx stall means that we don't wait for the last few bits to be read, which is good because we don't actually stall at all. If we were to stall, we just use the x value. So we have to have this set to false, otherwise this right here will never return. Well, here we go. And let's take a pause. Ladyada just pinged me, so she wants to show stuff. Develop Tyser, ask in the help with Arduino channel on Discord. Folks can help you there. There's also a forum that can help too. All right, Ladyada is not quite ready. Lantertronics Aaron says, hello from Georgia Tech Prof. These deep dives are excellent. Thank you. I'm glad you like them. I've gotten really positive feedback from folks, so I kept doing it. And they're definitely deep dives, but I'm, you know, as it goes, like I'm always happy to take 2 steps back and answer questions. Hugo says, right? I mean, people go through all this mess to get real random numbers, and here we are. Here we have them, but we don't want them? What's up with that? Ah, James and Eric say hello to Professor Lanterman. Okay, let's do. We'll get interrupted here when Lady Ada is ready, but logic. Let's show what it does. So here's the logic program. This is for the Celia. And so what I can do is I can hit start, and then I can just hit save and go back to the Celia. And it stopped, so it captured. And I'm using my thing to zoom out. Now I don't, the Celia, I have it set up to, so this like teal is the I2S Celia analyzer, and the purple is the one from, is the SPI analyzer, just on particular ones. And I'm getting all these errors on the I2S one, and I'm not sure why. It looks correct to me. I like counted each edge, and it like, cause it says like bits don't divide evenly between subframes, and I'm like, it looks exactly right to me. Oh. Hello. Yeah, sorry about that. Let me pop you out. No, it's good. We're talking about audio. And I got distracted. I was helping somebody with, well, I was redirecting somebody with Arduino questions as well. So they're gonna hop on the Discord. Are you in Chrome? Okay, yeah, it looks good. I was just making sure. Yeah, you look good. Is she very... Wait. Your audio still? No. Sorry, you're quiet. I had issues earlier. Properties. No, it's not you. I can hear you fine. They can't hear you. So you just keep talking. I had problems when I started as well. Device default. Okay, you folks can't hear her. I don't have, like, I named this desktop audio. Okay, say something, Lamore.
Hello.
How about now? That looks better on my end.
Hello. No? Yes? Maybe? Loud. Loudest.
Big from my headphones. Yeah, we might have to do Lady Ada charades. Oh, we get an ahoy. So we got you. We hear you now.
Oh, yeah? Okay.
Yeah.
Cool. All right, I was going to show off this.
Thank you all. Thank you, everybody.
Well, you know, we're doing it, whatever. So I got this CircuitPy2040. It's a RP2040 PCB in a STEMMA QT format. So to fit everything, because, you know, the chip needs 2 buttons and it needs like external flash, so it didn't fit on one side. I had to make it double-sided.
Right.
But you can see that it's got the same pin out. It's got a USB-C, 2 buttons. One is reset, one is boot select, and then there's a STEMMA QT port, which is kind of like the whole point of the whole thing.
Yeah,
and then
totally.
What's funny is because there's exactly 4 analog inputs. It actually kind of works perfectly because there's like 4 analog inputs labeled on the bottom.
Nice.
And then I'll show, this one is, I didn't finish putting together because like, I got one working and I was like, I'll get to it later.
Right.
So you can see the bottom of the PCB. And then I have one here. Let's see if I can get it to focus. So you can see the chip, the flash,
passives, it's pretty chunky.
And yeah, it's like I had to fit everything in there, but it'll fit, And another thing is like, I try not to use a 402 capacitors when I can avoid it.
Right.
I try to use those 603s because you get better, you get less, not dereferencing, but what's it? It's like derating. The capacitors derate the smaller they get, so to avoid that. But what's really nice is that you get this STEM QT. You can plug in OLEDs and sensors really easily. People love this, and it's like so easy. So this is display IO. This is just the REPL.
Right.
So even if I go over here, which I don't think people who use, like, they're not used to this with micropython, but this is like, I'm typing on my computer.
Right, we did like a bunch. We did a bunch of hurdles to make that work, but I think once we got it working, we were all like, "Oh, that's amazing!"
And then like up arrow like does the right thing.
Yep.
Yeah. So and it's just, I think that's really fun because what's interesting is you don't even, if you just have to print out text, you don't even need a GUI, right? Like you just want to have it display what's going on in the project. And I think you did display IO. Sorry, it's hard for me to type and get it.
I feel you.
Easy, RP.
I was doing examples with my mouse and keyboard. Yeah, I totally know what you're talking about. Oh
yeah, if you like doing HIT, you're like, oh my god, my mouse is like drifting off the side. Yeah, the REPL stuff came from the PyPortal, which you were like really fixated on. Okay, like we have to have the REPL show up, and I was just like, you're spending like kind of like 3 or 4 weeks on it. And I was like, oh man, like, if this works, it's good. But I was kind of like a little concerned. I was like, how long is this going to take? But when it worked out, I was like, this is like really sweet. I mean, it's really nice to have a REPL on the display. And it's, again, it's something that's completely alien to folks doing microcontroller programming because you never get that where like the low level RTOS controls the display, right? It's just such a weird hack, but like it works really great.
And the reason we did that is hold on, is Phil there? Can he ban the person in Twitch?
He is not. Sorry.
There's a question for you, which is what's your feeling? We were talking about this. What is your feeling on the flash that you're gonna end up putting on it, on the QtPy?
Yeah, so I was talking with Scott about this. So here's the good news. We actually have the flexibility to use any flash we want in CircuitPython. Like it's easy to add. Well, Scott's gonna add the little thing, but basically, folks, we're gonna make it easy. But basically, you just define what chips you're likely to use. And you have like 4 or 5 of them, and then it adds the support for all of those options. So I don't want to go less than 2 megabytes, or I don't want to do 2 megabytes or less because half of the flash is being separated for firmware, and I feel like 1 megabyte is not a lot. On the other hand, flash increases price. If people really want a 16 megabyte flash QtPy, like I'll make one for them. But I'm thinking kind of like 4 megabytes or something to keep the price reasonable, and then I can. The thing is, I can just pick and place on a 16 megabyte chip too. It's not a big deal.
Right. Yeah.
And
when I started working with you, I did the like drone stuff before, right? And like one of the failures I thought of myself doing hardware design was like not being cost conscious enough. And so I've always been really impressed with how cost conscious you are in everything you do in the Adafruit hardware. So, and I think it shows both in like Adafruit's success and that you have enough margin for hiring people like me, but also that you're able to, not only do you have that margin, but you're able to sell things at a really good price still.
Yeah, I think that's it's because we're going to be manufacturing the QtPy 2040 here in the US, and so it's like we pay people and we give them benefits, and they have 401ks and all that good stuff. commuter benefits. So, that's important to do. I have to look away from the screen because it's confusing because it's like slightly off. So
Sorry.
that's why I'm like, you're like, why am I staring up? Because it's like exactly 2 seconds, which is enough that your brain.
You're very deep in thought.
Your brain is, my brain is like, what's wrong with you? Okay, so the cost thing, it's a big deal because the bill of materials is involvable, right? Like once you set the bill of materials, you can get lower cost components, but at some point you do scrape the bottom, right? Like you can't really get PCBs any cheaper. You can't really get a USB connector any cheaper.
Right.
So, and also sometimes you can't get your low cost USB connector. You have to get it from a different place. So, or flash memory, like the price is variable. It's not a fixed price. Like it goes up and down.
Right.
So it's something that, I always try to be really mindful. Yield is another thing I have to think about. That's why I don't like using 0402s. Like I try to use the biggest components possible. Why?
Right.
Because the yield will affect your outcome. Like if you have a board and like you just don't have the right amount of paste and your adorably cute USON flash chip, right, which is what we're using, doesn't quite get enough paste, it's like you can rework it, but now you're spending like a minute or two reworking it, and it kind of like bounces, like that equals the amount of the labor cost equals the BOM cost. So it's like you want to really reduce yield, but use generic enough parts and make the final cost market compatible. And when I talk to big companies, they actually don't really get this, which is, it's a little sad. They're like, hey, like we're Megacorp, right? Like multi-billion-dollar company. And they're like, we want you to sell our feather. Like we're going to design a feather wing. And I'm like, I'm happy to sell it, but it has to be within like the market range. And they're like, okay, we used all of our sensors and made like a sensor feather wing. And I'm like, great, what's the price? And they say it's $75. And I'm like, nobody's ever gonna pay that. Like, like I'm happy to post about it, but I can't purchase 250 pieces because there's just no reasonable market where people are going to spend $75.
Right, you're never gonna sell all 250.
I mean, if I'll sell like and then like 1 or 2 people have a problem with it and they return it, and then like, okay, great, now you have even more inventory than you expected.
Right.
So cost is tough. I actually don't even know the price yet of the RP2040 chip, which means it's going to be, I have to find out what it's going to be. We're getting a reel of chips so we can get started on manufacturing again in a week or 2. So that'll be good. But yeah, I do have to think about it. It's like you can make 2 or 3 people happy by increasing the BOM cost. But you might make 998 quiet people unhappy because the price just went up by $2, or they won't even purchase it because they're like, why purchase it for $2 or $3 more? So it's not easy. I don't know the answer to it. I try to tell people, like people who come to me and they say, I have this product, how much do you think I could sell it for? I'll tell them, I think this is worth about like X dollars. I think this is what you can sell it for. And then it's just, you have to adjust what's in the design to match that. Make sense? It's weird. Sometimes you go backwards. Sometimes you say, oh, this is going to be $20. What can I fit? Like the Clue was like that, or the Feather Sense. It's like, what can I fit in this to match the final price I want to hit?
Yeah, totally. And it's also very surprising, or I think you also do a really good job at knowing what people want. And I think that's one reason to do show and tell and learn guides, right? Is like, that's how you can understand the things that people want to be able to do.
Yeah, I mean, being good at pricing in business is a totally different skill than being good at engineering. Like completely different. There's no intersection. And people are like, oh, but if I'm able to like figure out this SDK, how come I can't figure out pricing? Totally different. Like it doesn't relate. So I don't want people to feel bad if they're like, I don't know how to price my product. Also, some people surprise me. Like I've had people who, I'm totally not going to name names, who I don't consider to be great engineers. I mean, they're good engineers, but I'm like, you're not a great engineer. And they do pricing things that I don't understand. And it turns out like they were completely right. And I also know like really brilliant engineers, like the best engineers I know. And I'm just like, your pricing and market strategy is just like a total mess and it doesn't work out. Yeah,
that's where
totally different skill sets.
That's
Which
why
is fine.
when I had the
Whatever.
opportunity to just be paid by you to work on stuff, I was like, that is a much better fit for me. Like,
Yeah.
totally works out for me.
Yeah, like I mean it totally different skills, and it's I don't actually know for business even how you would learn it. There's
Right.
you can read books and you can read white papers, but it doesn't really teach you shit. Like you have to be in the industry for long enough to see what works and
Right.
what the price points and capabilities are. I mean, like I think I will say if you look at my controller boards, you can tell that like okay, it's going to be about 10 to 20 bucks. Like a microcontroller board, it's like unless you add more stuff, you have to kind of be in that range. Whereas for something like a Raspberry Pi competitor or something, you can't. It's going to be tough to sell something that's $100 because the price has been set by the Raspberry Pi to be about $40.
So I think we've asked this before, but work with economics, and I'm curious what are the profit margins are. I think you said basically what 30% for you and 30% resell. Is that what
Yeah.
it is?
So 30% is that's a good spot to be in. Basically, it means that you take your bill of materials cost because you might not know your assembly cost yet, and then you basically triple it. It's totally rough, but like it gives you some sense of it.
Right.
And then 1/3 of that goes to the distributor. So when
Mm-hmm.
you buy products from Adafruit, we get two margins, but a lot of people buy stuff from like our distributors on Amazon, or they buy them from DigiKey, or they buy them, their makerspace or whatever. And in that case, those people get one margin as well. So that's how you balance the cost and having the bill of materials. One huge mistake I see people, they only make the mistake once is they only add one margin and
Right.
then they get crushed.
Mm-hmm. Yeah, 100%. Whenever I've had discussions with folks, I try to be like, go on the high side. Like I know people like they want I know they want it to be inexpensive, but like really like um
It's easier to
you've
lower your price than it is to raise your price. That's what I always
right.
say.
All right, another question. Can I ask, has coronavirus affected your sales, and if so, has it been good or bad?
Yeah, I think so. I mean, like schools are closed. A lot of businesses are closed. It's been really tough. That's why we're really grateful for all the people who pick up something from Adafruit. The money does not go to any holding company. It goes straight to Scott, basically, and other employees.
Yeah, there's a reason I
Not
say if you
indirectly,
want to
but
support me, support Adafruit. Yeah.
yeah, I mean, like this is how we the money comes in and we use it to pay our rent. We use it to pay our people. Like there's no this is it. This is where we are a self-sustained company.
Right.
So the people who have been supporting us through it's been really great. And thanks to everybody. It's a really, it's been a really shitty year. It's been almost a year now.
Mm-hmm.
It's been really hard for everybody. But I know that there's people who are like, well, I'm at home and I want to learn new skills and I want to be creative and I want to do art projects and electronics. It's a great time to do it, and we are shipping.
Yeah, and I don't see all of it because I'm remote, right? And in fact, I was going to visit right when the pandemic started and didn't end up
Yeah, and
doing that.
we told everybody like, don't no visiting. Like, yeah, it was
Yeah.
right before the Open Hardware Summit, and
Yep.
like, yeah,
Yeah, but I did see like the production line was down for what, 2 or 3 months?
months.
And so
Yeah,
like there was
months.
definitely like the whole fab team did an awesome job like catching up to that. Right? Like
Yeah, there's a graph of like
they were
our
in a hole.
stock, and we were yeah we it was like there was like a point which we were like basically half of our stock we were out of stock.
Right.
We had some whatever we had in the store we were able to sell, and then people we'd ship them. But we were only doing essential manufacturing and essential sales.
Right.
We were making components for people making ventilators, for people making PPE, for people working on like health monitoring, all that. And so and also New York was on lockdown. I mean, to be completely frank, like people couldn't go out. So
Right. Right.
um, I was Was I going in? I think I was going in at night. I actually can't even remember anymore. But
I know you were doing that for a while.
I mean, yeah, I mean, I still do, but I'm saying like we were trying. I think we were doing the face shields, and we were doing very little manufacturing, just enough because we would have companies say, I need humidity sensors, I need motor drivers, we need microcontroller boards. And we're like, okay, like, well, you know, and they're like, we need them immediately. And I'm like, okay, we need them immediately. So, but we're back up now. We're running, and actually our stock numbers are looking pretty good. So thanks to everybody who's supporting us. It's been
that's awesome.
a journey.
Okay. Right. I know are you out of time, or can I ask you? There's a couple.
You can ask me like 2 more questions, but I'm exhausted. I'm gonna pass out.
Okay. There is. I can answer some of these questions. I'll do these quickly. Business model: sell hardware for more than it costs to make.
Yeah, there you go, Scott. You're great at business.
No, that's a hard thing to do, and you do it well. But that's the model, I would say.
Okay, well, yeah, and whatever's left over, you know, that's how we pay our staff. I mean, like, this is. I mean, anyone who is an engineer knows how much it costs to have a staff of engineers. We have a lot of engineering staff, specifically to support all the software. I mean, I know we just did a whole bunch of like Raspberry Pi script updates, and you know, Melissa did a great job at it. She's compensated for that.
Yep, totally. The other one I'll answer, which can we buy stock in Adafruit? The answer is no, because Lamar here owns it. But
that's good, because it means that no evil people can do it either.
Yes. The question I have for you is back to the Cutie Pie. You made a PR for the Cutie Pie this morning or last night, and I just wanted to say how did that go for you? Because I have this role of being an advocate for CircuitPython, and we're on the precipice of all of these RP2040 boards coming out and adding support for CircuitPython. So I as somebody who just added board support for CircuitPython, how did it go?
It was like really easy. And I'm not just saying that because Scott wants to hear that. I'm telling you the truth. I actually have a tried and true 20, 30 years of development technique for whenever I do pull requests or any code contributions, which is I copy and paste something that already exists and I edit it. So I took the Feather, or you can take the Pico, and I copy and pasted it, and then I went through each file and I renamed it. We have our own USB VID. That's the only thing that's a little bit challenging. But we do have tutorials, and we do give independent developers and one-off people. We can help them out if they need a VID. Otherwise, PID codes is the place to go. I think also the Raspberry Pi Foundation hopefully will go in. And then the only thing is I always forget to.
Have you asked them about the USB VID thing yet? I just pinged.
I have not.
I pinged Alistair about it in the Discord, so hopefully that'll get on their radar.
I think let them know. We'll see what they say. I mean, I don't,
It's a common thing for vendors
Obviously, they
to
must
do.
have
That's
one.
what I said. They do have one. I know that.
It's common. But if not, there's PID codes, and then also, we can help out independent makers and hackers who need a single one. I do want to say that I have to keep it within limit. We do have a lot, but we don't have infinite. And people are like, I need 25, and I'm like, hey, let's think about this. But the only thing then I have to remember to add it to the GitHub YAML file, and I always don't put it in alphabetical order. But other than that, it was only like, maybe 20 minutes of work. It's really easy because here's one of the things that I personally really like about CircuitPython compared to Arduino, which takes a lot longer to add a board support package, is you don't have to define each pin's functionality, because the chips pins functionality has been predefined already. Like which pins are PWM, which ones are SPI, which ones are UART. You don't have to, like in Arduino, you have to say like, at least with SAMD, you have to say like, oh, make this into an analog pin, or like,
interesting.
You know what I mean? Like you have to, I don't like it, but I get why they did it that way. You basically do a lot of pre-computation of which timer you want it to use. It's much more lower level. Whereas what I like about CircuitPython is you just say like, here's my pin names, and then I boot it up, and what's interesting about this design is there's two I2C ports. There's the one on the pinout, and there's one on the STEMMA QT. So you actually get two extra pins.
It,
Yeah, it turned out to be actually like it was right there, and I was like, yeah, let's do that.
Awesome.
So yeah, it was and then I just booted up, and then the only thing I was thinking is, do we want to have board.i2c1? I don't know if you want to do that or not for other designs that have
maybe.
maybe. All right, we'll talk about it.
I
No,
mean,
I'm just gonna bring it up.
like the board stuff is for like what is the default bus people are going to use, and on the QtPy, that's definitely like the STEMMA QT one. So
that's the one that I made I2C1 though, right? So it's like,
well, I would have that be
board.
I would have that be board.i2c, and then if we had like a board.i2c1, like one without the one and one with the one, like that's probably the way I would do it.
No, I know. Yeah, I gotta figure the fixed silk screen, so I gotta figure that out. And that's that.
Awesome.
So,
well, thanks for doing that PR. That PR is also like super helpful to point people to as they are adding their boards to the RP2040.
Yes, it's a. Oh wow, the building across the street, somebody moved in. The lights are on. Like you see like a place and it's always like dark.
Right.
And like the one time I look over and it's like all the lights are on and like the windows are open. Looks like somebody's gonna move in.
Airing it out.
I'll have something to look at while I'm writing code.
I know. We have snow on the ground here, which is rare for us. So
yeah.
All right. Well,
no, we still have snow.
I'm backlogged on questions, but I'll let you go before I get to those.
I'm getting out of here.
Yeah. So Lamore, ladyada, thank you for stopping by. She may stop by again in the future on this deep dive, but also there's Ask an Engineer on Wednesday nights if you have more questions for her specifically. That's the place
I just
to do
like popping by.
Totally. Well, thanks for hanging out. I have a little bit
of free time.
And I'll scroll back and get to the questions and do my best.
Cheers. All right, enjoy. Thanks, everybody.
Good night. All right. That was fun. Thank you for the audio patience. Let me look at the chat here. So we answered the business model. So Johnny says, when I order directly from Adafruit instead of from a local reseller, I get more money. No, I do not personally get any more money, but Adafruit would get more money if you buy direct from them. But if it's harder for you to buy direct from Adafruit, they still get some money if you get it from a local reseller. Developed, she's not going to add you on Discord, but you're welcome to ask me questions or stop by Ask an Engineer on Wednesday nights. But yeah, that's Ask an Engineer is a great place to ask business questions because Phil is there as well, and he's he manages all of Adafruit as well. First name 1, last name 2 says, new to all of this, is Pico a good place to start? Do you have a kit that includes all of the things to work through the Pico book? The Pico is a great, would I say it's a great place to start? If you're starting, I would actually start with the Circuit Playground Bluefruit is what my go-to board is actually. Let me pull that up. The Pico is great, so if you want to do that, that's awesome. But you're getting at what you're talking about. The kit with all the things you need for the Pico book, I don't know of anyone selling one yet. It's something Adafruit totally does, and I would expect us to do in the future. I think we've sold out of the initial Pico batch, so maybe when we get more of those, we'll do a kit. But if you haven't looked at it, the Circuit, not Python Playground, I'm in Learn, not in the shop. But yeah, so this Adafruit Circuit Playground Bluefruit is what I would recommend. Because it has a bunch of sensors all built in. And it has Bluetooth as well. So if you're just starting out, I would actually recommend that. Mr. certainly in the Discord points out the Clue, which has a built-in display as well. So Pico's good. It's perfectly fine. But if you want something that has all built in, the Circuit Playgrounds are great for that. Okay, I'm caught up on YouTube. Let me just see if I missed anything in Circuit or in Discord. Gareth says, well, Love the Factory said, can we buy stock in Adafruit? And Gareth says, I'd like to invest in Adafruit. So I don't think they're doing any sort of investment. They don't need it, as far as I know. If you want to invest in Adafruit, buy stuff. That's how you can get. That's how you can help support Adafruit, is by buying things. Dylan says, honestly, can't understate how difficult selling hardware for a profit is. 100%. Yeah. And there's certainly like the startup thing is pretty difficult too. Like Adafruit got past the hump of like having a couple products, right? Like they carry like 4,000 SKUs or something, and that makes it easier. Phil Moyer says, PID, Unix guy here, so you're probably not talking about process IDs. Yeah, it's product ID. So USB VID is vendor ID and PID is product ID. And VIDs cost $6,000 once to buy. So Adafruit has spent $6,000, or I think it was $5,000 at the time, but $6,000 now to get your own VID. They're 16-bit, so you have like 65,000 product IDs that you manage yourself. So what smart stuff can we do with two I2Cs, like PIO, to isolate two I2Cs? So the RP2040 has two I2C blocks, so you probably don't even need PIO to do that. Yeah, J Foreseen says you could have I2C, I2C0, and I2C1, where I2C and I2C0 are the same. Yeah, that would work. Yeah, technically snow, but it looks like heavy frost. Yeah, not much. Okay. There's a micropython on Pico book. Yes, there's a physical book for MicroPython on Pico, and then we've also cribbed the examples out of there and translated them for CircuitPython in the Learn Guide. Which is getting started with Raspberry Pi Pico. And here you can see that we have like this reaction game, and we say like, hey, by the way, we ported it from the book. Johnny says Pico is too new. Better to get a board that's been out for some time. Then you will find projects on the internet. So yes and no. Like one of the nice things about the way CircuitPython's built is like once we have the module for something, like all of the examples code should just work. And Beck says you can get a return from Adafruit by buying their stuff, learning how to make things, and then selling that or starting your own business with what you learn. Yeah, invest in yourself. Mark Olson asks, do you have any idea why I2C might be really slow on Blinka devices, the FT232 or the MCP221? I don't. I have not used either of those at all. I would ask Carter. Carter's done some work with them, and he may have an idea. If you don't have a logic analyzer, my guess is usually what happens is that like the actual transaction for I2C is really quick. It's just like everything else around it, going from one transaction to another is slow. That's what I would suspect if you're seeing like slowness overall. GP0 and GP1 are for I2C0, but they're also TX and RX. It depends on how they're hooked up to the board. Like all of the I2C01 things are like copied across all of the pins. All right. Any other questions? Otherwise, I really want to just see if this I2S stuff works, but I'm not sure I have enough time to do that. We could play some audio. We got 20 minutes or so. Zach points out that getting started with Pico book is also available as a PDF now, so starting out with Pico is not an issue if you plan to follow the book. That's true. First name one, last name. PyCom seems like a great board with lots of examples. Any opinion on that? I do not know the state of the PyCom MicroPython port, but my understanding is that it's a separate version of MicroPython that is not CircuitPython or MicroPython, like upstream MicroPython. So if you want to stay in the PyCom ecosystem, that is fine. It's kind of similar to like the CircuitPython ecosystem where we have lots of libraries and stuff like that. My bias is to say, no, I wouldn't do that. But if you want to, it's up to you. I think that starting off like Adafruit's focus is people who are getting started for the first time. And that's not true for a lot of things. P-Boy says, I have 10 PyCom boards I abandoned because it was too vendor specific. Phil says 2 hours, 15 minutes to sailboat racing so I can hang out. Demo time. Okay. First name asks, the most basic reason to use CircuitPython over MicroPython. This is something we talked about, but the pitch for CircuitPython is one, our user experience is consistent across all of our devices. Means you plug it in, it shows up as a CircuitPy drive, and you edit the code.py on the drive. That's true for all of the boards, almost all of the boards you can see on the downloads page. We do have downloads for ESP8266, which it doesn't work on, but we don't support any. So that's one thing. The other thing is we have a strict hardware API, which means that all of the libraries and example code based on those APIs applies to all of our versions, all of our ports. MicroPython does not have that. They have an API they try to keep standard, but it's not quite standard. And they don't have the library catalog built on top of that. So I'm trying to be objective, but I'm biased obviously as well. Ryan says, is I2C peripheral support planned for the RP2040? No. I mean, I would merge it and I would review and merge it if somebody added it, but it's so far down my list that I don't think it's not something that I feel like I need to do before I like moved on to BLE workflow stuff I want to do. Largely because what we've been talking about of like our focus, Adafruit's focus, right? Remember, Adafruit pays me, right? And so like my focus is on the beginners, what do they need? And I2C peripherals is just not one of those things. So if somebody wanted, like the I2C peripheral API itself was something added by someone else as well. So like it's doable. The chip can do it. I'm happy to help you do it. I'm happy to guide you in doing it, but I don't think we'll do it. At least not in the short term. I think it's more likely that somebody not paid by Adafruit does it. David says, but then when we grow up, we will not be the target of Adafruit and CircuitPython. Where do we go then? This is a sentiment I think that gets people in trouble. This idea that like once you're an expert, you're no longer our audience. And I think that is true. So much of the work that we do for beginners is benefits intermediate and experts as well. And there's always going to be more beginners than intermediate and expert folks. I think the expectation for us is that experts can do it themselves. And it's all open source. You can start with the code. You can add stuff in CircuitPython if you need it. Nerodox says, when we grow up, we make satellites, right? Like that's a good example, right? Like that is an expert use case. Max Holiday, who did the satellites, like he made pull requests to CircuitPython that I reviewed and we merged in. Like we have support for, I think it's MRAM, like magnetic RAM, which is used in place of flash. Like that's in there because of Max's work. So like my goal is to get to enable anybody to contribute, but the contributions I will make will be towards the beginner focus stuff. David says, talk about the CircuitPy2040 Midy synth. I don't know what you're referring to. Like, it'll be able to do Midy for sure. Like we have Midy working on RP2040 already. Gareth says, I'm using Adafruit hardware and libraries in production IoT devices. Yeah, it's doable. And then Dexter asks, is there a UF2 bootloader upgrade for the CircuitPy M0? I don't know. You'd have to check. If you open the boot drive, you should see info.txt, something, info that will have the version in. Oh, Midy in, sound out. Somebody could do it. I don't know of a demo, but I don't see why you couldn't do it. Phil Meyer's working on a CubeSat controller board. Dexter, compared that version number to the UF2 SAMD repo. I'll show you it. Go GitHub Adafruit UF2. I have it in my history. This is the source for it. And it looks like 3.12.0 is the latest. So yeah, you could probably update it. Whether that actually impacts the CircuitPy M0 or not is a separate thing. I don't know of any. If it works, then no need to update it. Topbot says, speaking as a sort of expert, Adafruit and SparkFun are great resources because they're doing excellent documentation work on making these complex chips usable via CircuitPython and Arduino libraries. I'm always on their GitHubs learning about chip internals. Yeah, I think that's true. I think a lot of experts use Adafruit and SparkFun to basically accelerate learning something, and then it makes total sense, right? Like, quickly learn the basics, and then because you're an expert, you can learn the expert thing that you need to know. Johnny says, even when you're grown up, you buy Adafruit boards for prototyping, as that is way cheaper and simpler than doing them yourself. Okay, let's do a little bit of audio. Should we just go for gold and see if it works? Actually, you know, I don't know. The problem is I don't think I have it compiling yet. Should we just see? So what I did right before the stream is okay, you can see my screen. I added the program stuff. I'm sure there's compilation errors here. But I kind of want to just go for broke and see if I2S works. Oh, it compiled. What are the odds that it works? Slim? I don't even know if I have it on. Let's just see. We're skipping ahead. We're not picking up where we left off. But it's probably not on. So we got to turn the module on. I really wanted to get I2S done this week. So, okay. We're going to turn audio bus on. Let's go for broke, huh? Odds are 2040. Okay, we're gonna probably have to clean again. It just might work. It compiled, but the code that I changed was not included in the compilation, so. Nerdoc says, I absolutely would recommend using CircuitPython for prototyping on any project where you find you can do it. This is what I expected. This is what I expected to happen. Have I shown wading through this stuff? So, okay, so let's just do it. Let's just see how far I can get. Maybe I'll be able to get it. I don't know, 7 minutes. We can run over a little bit, but I don't want to run over too much. Okay, audio bus IO, PDM in, Atmel start pins. Clearly you can see where I copied that from. And so I think we just need to clean out all of the, so I want to do PDM in as well. this? Must be clocked at least. Invalid pin. Serializer in use. I'm mainly just keeping the error messages that I think I'm gonna need, and then I'll comment everything else out. So PDM is another version of digital audio that is the density of ones indicate the value. So it's like a whole lot of 1-bit samples, and then you do math to figure out what the real, or like the 16-bit equivalent is. So, oh, we're not going to need these either. Oh, come on. Okay. And all this clock unit stuff we don't need. It's pretty awesome. Like, a lot of this just doesn't, we don't need it because we're going to rely on, we're going to use the PIO to clock these bits in. So right now I just want to get it compiling so that I can test the other thing. And again, I think I'm just going to, I probably would have saved myself time starting from the I2S example. Here's all this setup DMA stuff I don't need. I don't think I'm going to use DMA with it either. This sync filter stuff is the stuff that I need. So let me just comment it out. I'm just trying to like get this working. Get the compilation errors gone. And I'm gonna clean again just because I fixed the headers. Johnny says, I just realized I've been watching live streams continuously for 7 hours. That's dedication. Okay, so now these are I2S problems. So did I mean number? Yes, I meant number. And the state machine. Okay, so in here, we need to include common hell RP2040 state machine. Just lazy. You're like laying on your couch and your TV's just rolling from one to the next. And then, let's see here. The pin check is wrong. This is the sort of work that's like really good when your brain's fried. It's like very basic stuff. Unknown type. That should have fixed it. Discards const qualifier. I think it's okay if the const is there. Const kind of makes things marks them as read only. If you're new to this. State machine obj T. I'm surprised that didn't work. In I2S out.h. Oh, did I put it in the wrong place? I did. I'll copy it because I know I'm going to need it there as well. Oh, I got to tune that. I got to tune the sensitivity. It's not quite right. One tip if you're new to C, I always start with the top errors because sometimes an error at the top causes the other errors further down. And so it's always good, I think, to start at the top and work your way down because you might fix one and then have a bunch disappear. Okay, so this is just a copy and paste error. We're just not calling it. Obviously, this is... When I'm doing code like this, it's really like... How would I describe it? Like I write a bunch, and then I fix it. And then once it compiles, I fix it some more to make sure it actually works. Oops. Too many ends. I'm loving this new CPU. It makes it so quick. Okay, that's interesting that it's seeing this is the private version that we have for NeoPixel, but we're not using the basic one, which makes me think that at the top here, if it starts with common HAL, it is usually in the shared bindings version. So I think it's RP2040 state machine.h. And that should fix that. And PDM's complaining as well. I suspected this would be the case. So let's just replace that with a 0. I think that's like, how many samples did you get? Ah, it's not shared bindings, it's bindings. Because it's a funny case where it's port specific. Shared bindings is for the stuff that's not port specific. Oh, look at that. I've got less than screens full, which is good. Too few arguments. And then this audio sample bits per sample is not there. I think it's in... Here's the function. So we'll want that as well. I think that's right. Sorry, I'm in heads down mode trying to get it fixed. Okay, so the question is, which arguments are we missing? So I thought I copied it, but maybe I think I added more arguments. So we have program, frequency, init program, which is program frequency, init, and then 4 pins, exclusive pin use. Oh, txstall. Okay. So I was thinking this is like that. This is the bad side of C. So like most of these parameters are keyword args in Python, meaning that they have a default value. You don't have to provide them in order because you always have to give their name, and you only have to give the ones that you want a non-default thing for. But in C, there's no such thing, and so in C we end up having to do all of the parameters all of the time, which goes to show how much nicer Python is. Okay. Let's see if that's the right number. And it is. Awesome. Okay, let's test it. So I'm going to go away. Remind me to change my camera when I do my wrap up. Because I'll do this, and it looks like it's live still, which is awesome. The USB on this new motherboard's been so much better. So what I'm going to try to do first is I think I'll just try to change the example I have from using PIO back to using audio bus IO. Big E asks, can Sublime render Markdown? I think so. I'm not sure. I think they have a mode where you can have like a second panel with it. Okay, so what I'm going to do is I'm going to hold... Actually, I'm going to make sure I'm ejected. Which I think I am. Well, I think I did now. And now I'm going to hold boot select and press reset. So get me in the bootloader. And then I'm going to ports. I got to tune that. The proximity's throwing me off. I feel like it got worse. Okay, feather. Firmware. I want it. Not a CircuitPy. Try it again. There we go. The CircuitPy that's showing up is the timestamp thing. Copy. Sorry if you can hear the vacuum. All right, took a little while, but now it's going, and we should see CircuitPy again, and that's the one we want. So I'm going to... P-Boy says, one of the nice things about CircuitPython versus micropython is the reusability of libraries. In micropython, many libraries are port-specific, where CircuitPython has common layers, which increases the portability and the community and my deep dives. Toddbot says, yep, I use streams like this to help me do work. Working alongside someone, even though I'm working on something totally different, helps. You're welcome, Toddbot. And thank you for sponsoring me. Mr. Certainly is a sponsor as well. Scott, you and your work always be valuable for engineers, even those who grow up to be experts. Yeah, that's my opinion too. Okay, let's duplicate this and say this is... I'm actually going to want to use this later, because I want to add this as an example. Okay, so we've got our code.py. And let's switch it back to playing audio bus IO. So here's how we convert it back. We don't need that anymore. Don't need this. And DAC now becomes audio bus IO.I2S out. And let's pull up the docs for that because I can't remember. C says, this is because there is an important portion of expert engineers that continue their growing up process to become mentors and can tell their new hires, go check me out at Adafruit. Did I checkpoint the matching code and get? No, I didn't. Everybody's like very worried about losing their state, but it's really when I'm going to restart my computer, because generally I have a copy of something in my editor. I just really, like, worst case I write it again. Garrett says +1 for deep dives driving hardcore users into becoming contributors. Yes, the deep dives I think have had an impact. I think we've definitely seen folks come out of the community to contribute, which has been amazing. It's amazing. Like, I really want this project to be bigger than Adafruit and getting non-Adafruit funded people, ideally people funded by other people working on it, has been great. And oh, I'm not in product mode all the time. Just means the focus will be a little bit better. Okay, let's do I2S out. And we give it bit clock, word select, and data. And how did I have it arranged? Trying to remember. Bit clock was board.d10. Word select. Board.d11, and data was board. I think I can do it with the arguments d12. And then left justified is the only other thing to give it, which we don't want by default. And instead of DAC right, we want play. And we also want a loop equals true. And where's my terminal? I have it here. I'm just bit clock argument required. Let's just see what this does here. Oh, it's bit underscore clock. Alvaro says, for me, CircuitPython is cool because I can talk to a scientist or a park ranger in places without internet. So go and change a file to fix a project. Undoable with any other language I can think of right now. So you can send them out and they use USB to update the device. Exactly. Okay. It still crashed. Array object does not support protocol audio sample. That's true. Oh. All these ends. Sample equals audio core dot raw sample S16 and what was it? Baud rate? Sample rate? Sample rate? That's my guess. 8,000. Oh, it's doing something. Maybe it crashed. Gareth says, I have to spend weeks teaching folks to compile in Flash C. Exactly. Oh, and it printed done, but it didn't give me a prompt. Can I control C it, or am I think I'm hung. There's a bug. Okay, so what I'm gonna do is I'm gonna just ignore the fact that it doesn't work at the end, and I will eject it. And then, oh, I don't have a cable that's non-data. But I just want to take a peek at this. So I'm just going to hit the reset button. So I'm going to start. All right, it's not going now, so it did manage to stop. So I just hit reset, and it looked like we captured something. And the drive popped up. Come on. Nothing. We got... Oh, I guess that makes sense because I'm not initializing the pins the same way. Use Windows and you won't have that problem. That's not true. You can still have problems with Windows. You can always have problems with Mac too. Okay, so the problem is that I haven't done the pin initialization stuff, which is unfortunate, and it's also gonna take... Wonder if I can cheat it the way that I was also cheating it. Okay, in I2S out, what we're gonna do is we're gonna do, this is what we should do, but we're gonna do word select 3. We're gonna do the same pin initialization that we did last time. Oh, you know what? I don't think I know the set. There's like one command that I need here from the other example. Okay. So if you noticed, I do as test, and rename this to code. Hey, I did start using TO again, folks. Again, or oh, did it? Is it? It's interesting. It's hung, but the USB is fine. So let's eject and reset again. Ooh, Bruce got CircuitPython compiling with IDF 4.3. That's good. All I want is I want this number, E087. E087 is the magic incantation init. I can make it const. Init. This is totally a hack. This is not going to be in the final PR. I used to like curl my hand more now. Make eject boot cell, load it up. Just because my Mac hangs twice a week doesn't mean I have a problem with it. Oh, come on, I don't have, there it is. Copy, 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 copy. I am overtime. I don't really want to go outside though. I usually go outside after, but it's cold. Okay, so that's still running. But I'm going to change the example again. PIO-I2S. And then before I rename this one code.py, I'm actually going to get the Celia going because it will probably still hang on the way out. So rename this code.py and sync to make sure the file system gets written. And we captured something. Hey, look at that. We've got some. What do we have and what do we not have? Interesting. Look at that. The frequency change. So we do it looks like we're like shifted. Right? Like this is clearly the left-right clock and this is the, what pins did I say? D12 should be data. Let's see if we're... Progress. I was hoping to hook it up to an amp though. That's what I was really hoping for. Yeah, and see we're hung here again. Which probably means So this is I know I'm over time, but this is a good question. How do you figure out where you are? Because we know our code.py is completely done. We printed done. And we know it's I2S related. So the question is, where are we? It's possible we're in state machine reset. Come on. That's another thing I gotta do. I gotta tune this proximity thing. Ms. Puckman says it's great you are showing us troubleshooting tools along with coding. Most videos don't do that. Yes, I'm an open book. And this is all part of programming. And having techniques for debugging is definitely something that's really hard to pick up. It's not something that's often taught. That's my guess as to where we are. Let's just copy it over again. Tio's been great. I don't know. I know folks have mentioned it to me before. Tio is great because it automatically detects and reconnects. TCD says what? Oh, sorry. What debugging tools do you have to get a stack dump / program counter? I could have a JLink on it and then be doing it in GDB, and then I would be able to just Control C and see where I was. But I'm also like, I haven't set it up yet, and I'm about to have weekend, so it's just not that interesting to me. Although it looks like the problem is that it looks, I think we hung before we got USB. Like we're playing back before we ever get USB. But USB is active. It's just not like the reset's never finishing, which is weird. But there's a simple thing we can do, which is type ends into everywhere. Not really. In our example, we can just add a wait. Oldest trick in the book. 10. So that's to give USB time to that. And if it was actually hung, we wouldn't be able to like safely eject it. It would complain. So now we don't actually need to load a new one, so we'll just hit reset. Isn't 90% of coding figuring out why it doesn't work? Yeah, I think that's a fair thing to say. Okay, it's going. Oh, so we do get done. So we got the second done. We got reset state machines, and we got done. Weird. I don't know where we are then. This is probably a time I would actually just need to use the JLink. It's on the same line because I didn't add the new lines. I don't really want to do that. So I think, where are my pins? D12. Why is my pinout wrong? Data is D12. That's right. So my pinout's wrong. I'm going to try to get it going. I'm going to ignore the fact that it hangs. Out pin 1 data. Side set pins. Starts at word select and is 2. Start at word select D11 and goes 2. Am I plugged into the wrong? 10, 11, 12. 10, 11, 12 is right. But I'm going out the wrong places. Let's just capture it again. Crashed it. J-Link for Monday, yeah. Cable Tie says, is JTAG debugging support available for the RP2040? It's not via JTAG, but yeah, what you're thinking of is. It's called, the protocol is SWD. And there's an example on how to do it from the Raspberry Pi to it, but J-Link actually just had the initial support for it in their beta, which is what I'd rather use. I have a Raspberry Pi here that's been heating my office for a few months now, but I would rather turn it off. Okay. All right, let's call it. This is nothing. My Celia is so unhappy. USB is so hard. One more try. Go make a tiny snow person. There is not that much snow. I think tomorrow is going to be a snow day. All right. I just want to see. Oh dear, did I? Oh, I was going to say, did I jinx myself? It's still the wrong pins. We got the side sets, but the side sets are in the wrong spot. Oh no, that's the right spot. That is the right spot. D12 is purple. Huh. Looks like an looks like an off by 1 error. I'll keep working on it, but I'm gonna call it. Hot meal and a favorite TV show. Awesome. All right. Thank you all so much for hanging out with me for these 2.5 hours. Thanks again to Ladyada, Lamore, both for stopping by and showing us the QT RP2040, but also for sponsoring this stream and all of my work on CircuitPython. Adafruit is her company and makes all these things possible. So if you want to support me, you can support Adafruit pays me, so support Adafruit by going to adafruit.com. If you want to chat with me and a whole bunch of others on the Discord, you can go to adafru.it/discord. If you're getting started and you have questions, that's a great place to do it. This has been a deep dive. It's more of this every week, Fridays at 2 p.m. Pacific. I live in Seattle, so Seattle's time zone. Every week. Next week is on Tuesday. Not Tuesday. I saw Tuesday somewhere. Next week is on Friday, like normal, not on Thursday. So if you have questions, either ask them on the Discord or you can ask them of me next week during the deep dive. Keep an eye out for this audio work. I am close. I feel like I'm close. Like the code is written, it just needs to be debugged and have these issues ironed out. So I might actually keep working on it after the stream. So keep an eye out on the CircuitPython Discord channel in particular. That's where we do all this development. If you're new to CircuitPython, please say hi. We'd love to have you. If you're new to programming microcontrollers, there's lots of great tutorials on learn.adafruit.com. Thanks again to David, DCD, for taking timecodes. They'll go in the description here after the fact so people can skip around. And as always, thank you so much for everybody hanging out with me, and I'll see you next week. I think this week we'll end with a petting Vin, since she's actually here, not locked out of the room. So have a great weekend, everybody. If you are going to the CircuitPython Weekly, remember that Monday's a U.S. holiday, so it'll be on Tuesday. So be aware of that if you're planning on making it. Hi, girl. Am I ruining your do? All right, cheers, everybody.